So now we're on section 8.3 and we're doing question 25. And here's the triangle and its identities that correspond to the given information. And so in this case, secant theta equals the radius over the length of the side adjacent, and so that's 1x over 1, and so x equals 1 times secant theta, or secant theta. Dx equals secant theta tan theta d theta. Now the square root of x squared minus 1 equals, well, let's see, the tan of theta equals this over 1, so this equals 1 times tan theta, or tan theta. And so now we can rewrite our integral in this form, and this using the substitution secant theta tan theta d theta divided by, and this is going to be 3 factors of tan theta. Well, 2 factors multiplied together will be tan squared theta, and 1 more factor of tan theta will just be tan theta. Now these divide out, and so we have the integral of secant theta over, and tan theta is the same as tan squared theta sine squared theta divided by cosine squared theta, but when you invert and multiply, you'll wind up with a cosine squared theta up here, d theta. And this equals the integral of, and in the denominator we have sine squared theta, and secant theta is the same as 1 over cosine theta, so cosine squared theta is the same as cosine theta times cosine theta, and secant theta is 1 over cosine theta, so one of those factors divides out, and so now we have the integral of cosine of theta over sine squared of theta. And by the way, I need a d theta there. So now let's do a little u du substitution. So if u equals sine of theta, du equals cosine of theta d theta. So now we have the integral of du over u squared. And that becomes negative 1 over u plus c, and which equals negative 1 over sine of theta plus c, which equals negative, and sine of theta is going to be the square root of x squared minus 1 over x, so I'll put the square root of x squared minus 1 over x, but you invert and multiply, so this x will wind up in the numerator, and we get a plus c, and we're done.